This is an audio-visual presentation on surface area and volume of solid figures. Now, these are the solid figures that we are going to consider. We will consider the cylinder, the cuboid, the cone, the sphere, and the pyramid. So these are the solid figures that we are going to consider. Now, we start with cylinders. A cylinder is a prism with a circular cross-section. An example of a cylinder is the milk or the Milo tin. Now, considering the cylinder as shown, we have R, that is the radius of the circular end, and we have the height, that is H. So with a cylinder, we have the radius and the height of the cylinder as shown on the diagram. The curved surface area of a cylinder is equal to 2 pi RH. Now, when we consider the cylinder as shown, the blue shaded region is the curved surface area of the cylinder. So the curved surface area of a cylinder is equal to 2 pi RH, where R is the radius of the cylinder. That is, R is the radius of the circular end. H is the height of the cylinder, and pi is a constant. So if you are asked to calculate the curved surface area of a cylinder, then the formula is equal to 2 pi RH, where pi is a constant. R is the radius of the cylinder, and H is the height of the cylinder. The total surface area of a closed cylinder. When we say a closed cylinder, that is a cylinder closed at both ends. A cylinder has two circular ends. We have one circular end at the top and one circular end at the bottom. So if you are considering a closed cylinder, then it means that both circular ends are closed. So the total surface area of a closed cylinder is equal to 2 pi R square plus 2 pi RH. Now let's consider the cylinder as shown. We have one circular end at the top, and we know that area of a circle is equal to pi R square. That means that the area of the circular end at the top is equal to pi R square. Now the blue shaded region is the curved surface area of the cylinder, and it is given by 2 pi RH. We also have a circular end at the bottom, and because area of a circle equals pi R square, that means that area of the circular end at the bottom is also pi R square. So if you are calculating the total surface area of a closed cylinder, it means that we have to add the area of the three regions. We have to add the areas of the three regions. That's the circular end at the top, the curved surface area, and the circular end at the bottom. So the total surface area is equal to pi R square plus 2 pi RH plus pi R square. Now total surface area equals pi R square plus 2 pi RH plus pi R square. Now 1 pi R square plus 1 pi R square will give us 2 pi R square plus 2 pi RH. Take note that the coefficient of the pi R square equals 1. That is why it's not seen. So when we add the 1 to the 1 we have at the bottom here, 1 pi R square plus 1 pi R square will give us 2 pi R square. That is when we add pi R square to pi R square, the result is 2 pi R square plus the curved surface area, that is 2 pi RH. So in general, the total surface area of a closed cylinder, that is a cylinder closed at both ends, is equal to 2 pi R square plus 2 pi RH. The total surface area of a hollow cylinder with one end opened is equal to pi R square plus 2 pi RH. Now let's consider the cylinder as shown. Considering the cylinder, we can see that the circular end at the top is opened, and that makes it a hollow cylinder. So the circular end at the top is opened. Now we have the blue shaded region, that is the curved surface area, and the curved surface area is given by 2 pi RH. The circular end at the bottom is closed, and the area of that circular end is pi r squared. So if you are calculating the total surface area of a cylinder open at one end, the answer is equal to the formula that we are going to use will be 2 pi RH plus pi r squared. This is because one end is opened. So we can see from the diagram that the circular end at the top is opened. And that means that if you are calculating the total surface area of such cylinder, it will be equal to 2 pi RH plus pi r squared. And 2 pi RH plus pi r squared will be equal to pi r squared plus 2 pi RH, where pi r squared is the area of the circular end at the bottom, and 2 pi RH is the curved surface area. The total surface area of a hollow cylinder with two ends opened. Now in this case, all the circular ends are opened, and so the total surface area of a hollow cylinder with two ends opened is equal to 2 pi RH. Is equal to 2 pi RH, where 2 pi RH is the curved surface area of the cylinder. Now let's consider the cylinder as shown. We can see that the circular end at the top is opened, and the circular end at the bottom is also opened. So the only region we can consider is the blue shaded region, that is the curved surface area. So if you are asked to calculate the total surface area of a cylinder opened at both ends, it means that the total surface area will be equal to 2 pi RH. The total surface area of a cylinder opened at both ends is equal to 2 pi RH. Volume of a cylinder is equal to pi r square h. The volume of a cylinder is equal to pi r square h, where pi is a constant, r is the radius of the circular end, and h is the height of the cylinder. So if you are asked to calculate the volume of a cylinder, this is the formula we have to use, that is pi r square h, where pi is a constant, r is the radius of the cylinder, that is the radius of the circular end, and h is the height of the cylinder. Example: a cylindrical tin with one end opened has diameter 140 millimeters and height 50 millimeters. That means that the cylinder has diameter 140 millimeters and height 50 millimeters. So the height is 50 millimeters and the diameter is 140 millimeters. Now let's proceed. Calculate the area of the base, curved surface area, total surface area, and volume of the tin. Now take pi is equal to 22 over 7. So pi is a constant, and from the question we have to take pi to be equal to 22 over 7. That means that wherever you see pi in any of the formulas you are going to use, you have to substitute the pi by 22 over 7. Now let's proceed and see how best we can solve this question. Now from the question, you were asked to calculate the area of the base. The area of the base. Now solution. From the question, we were given the diameter but not the radius. But we know that the radius is equal to diameter divided by 2. From the question, the diameter was given to be 140. So when we divide the diameter by 2, that is 140 by 2. The answer is 70 millimeters. So the radius of the base is equal to 70 millimeters. The radius of the base is equal to 70 millimeters. Take note that when you divide the diameter by 2, you will get the radius. And so dividing the diameter, that is the 140 given in the question, by 2, the answer is 70 millimeters. That means that the radius of the cylinder equals 70 millimeters. Now we were asked to find the area of the base. Because it's a cylinder, the base is a circle, it's circular. And we know that area of a circle equals pi r squared. So the area of the base will be equal to pi r squared. Pi is a constant, and from the question, the constant has been given to be 22/7. Now r is the radius, and from our calculation, the radius now gives us 70 millimeters. The radius is equal to 70 millimeters. So area of the base, which is equal to pi r squared, by substitution, this is equal to 22/7, where 22/7 is pi, times 70 squared because of r squared, and r is equal to 70. So instead of r squared, is equal to 70 squared. So the area of the base is equal to 22/7 times 70 squared, and this is equal to 15,400 millimeters squared. 15,400 millimeters squared. That is the area of the base. Now let's proceed. Curved surface area of a cylinder is equal to 2 pi rh. The curved surface area of a cylinder is equal to 2 pi rh. So this is equal to 2 times 22/7. That is, instead of pi, we substitute pi by 22/7. That was given in the question. Times r, that is the radius, which is 70. Times h, that is the height. From the question, the height of the cylinder is 50. So the curved surface area is equal to 2 times 22/7 times 70 times 50. And the curved surface area is equal to 22,000 millimeters square. The curved surface area is equal to 22,000 millimeters square. So what you have to know is the formula. That the curved surface area is given by 2 pi rh. So what you have to do is the substitution. Wherever you see pi, you substitute pi by the constant given, that is 22/7. And wherever you see r, that is the radius, you have to substitute the radius, that is 70 from the question. And the height from the question is equal to 50. So when we multiply 2 by 22/7 by 70 by 50, the answer is 22,000 millimeters square. So the curved surface area is equal to 22,000 millimeters square. Now total surface area. Because one end of the cylinder is opened, the total surface area will be equal to pi r squared plus 2 pi rh. That is the total surface area of a cylinder open at one end. So total surface area is equal to pi r squared plus 2 pi rh, where pi is a constant, r is the radius, and h is the height. So by substitution, the total surface area is equal to 22/7, that is pi, times 70 squared, that is r squared, because r equals 70, plus 2 times 22/7, where 22/7 is the pi, times 70, where 70 is the radius, times 50, where 50 is the height of the cylinder. So 22/7 times 70 squared is equal to 15,400 millimeters squared, plus 2 times 22/7 times 70 times 50 is equal to 22,000. So we have 22,000 millimeters squared. Now the total surface area will be equal to 15,400 millimeters squared plus 22,000 millimeters squared, and this is equal to 37,400 millimeters squared. That is the total surface area of the cylinder open at one end is equal to 37,400 millimeters squared. Now IV, volume of the tin. Volume of a cylinder is given by pi r squared h, because from the question the figure was a cylindrical tin. I repeat, from the question we were given a cylindrical tin, that is a cylinder. So volume of the tin is the same as the volume of the cylinder, and the volume of a cylinder or the tin is equal to pi r squared h, where pi is the constant, that is 22/7. R is the radius, so instead of r squared we have 70 squared, times the h, and h is the height from the question. So 22/7 times 70 squared times 50 is equal to 770000 millimeters square. That is 770,000 millimeters square. So the volume of the thing is equal to 770,000 millimeters square. Now, when we consider a pipe also has a cylindrical shape, but because of the thickness, we have two different radius. We have the inner radius, that is small letter r, and we have the outer radius, that is big R. Now the cross-sectional area will be equal to pi r square minus pi r square. Take note, it is pi r square where the big R is the outer radius of the pipe and the small r is the inner radius of the pipe. So the cross-sectional area of a pipe is given by pi r square minus pi r square. Now let's consider the cuboid. A cuboid is a prism with a rectangular cross section. A cuboid is a prism with a rectangular cross section. Now this is an example of a cuboid. We have the length, we have the breadth, and we have the height of the cuboid. Take note that the length, that is A to B, the distance from A to B is the length, and the distance from A to D is the same distance from H to C, is the same distance from F to G, and the same distance from E to D. So the length is L. We have the breadth, that is B. The distance from B to C is the breadth of the cuboid. The distance is the same as A to H, and it's equal to the distance from F to E, and is the same as the distance from J to D. That is the breadth of the cuboid. Now the distance from C to D is the height of the cuboid, and the distance from C to D is the same distance from B to G, is the same distance from H to E, and the same distance from A to F. So with the cuboid, we have the length, we have the breadth, and we have the height. Now, volume of a cuboid is equal to the length times the breadth times the height. Volume of cuboid equals L times B times H, where L is the length, B is the breadth, and H is the height of the cuboid. So the volume of a cuboid is equal to the length times the breadth times the height. Now the total surface area. Let's look at the total surface area. How to calculate for the total surface area of a cuboid. Now, when you consider this cuboid, our concentration is on the red shaded area. We can see that the bottom, that's the part of the cuboid on the ground, is A, B, C, H. That is the red shaded region at the bottom. Now, the region A, B, C, H is the same as the region E, F, G, D. Take note that the red shaded region at the bottom is equal to the red shaded region at the top, because the distance from A to B is the same distance from F to G, and the distance from B to C is the same distance from G to D. So the region at the bottom, that is A, B, C, D, is equal to F, G, D, E. Now we can see that area of the region A, B, C, D will be equal to area of the region E, F, G, D. So when we calculate the area of the rectangle A, B, C, H, is the same as area of the rectangle E, F, G, D. So we can calculate the area of the base, that is A, B, C, H, and multiply the answer by 2. At the end of the day, we are getting the area of the two regions because they are all the same. Our concentration is on the red shaded region. Take note. Now, considering the rectangle ABCH, that is the part of the cuboid on the ground, and it's equal to the part above, that is EFGH. Now let's consider the part of the cuboid on the ground, that is ABCH. If you want to calculate the area of this rectangle at the bottom, it is the length times the breadth. It is the length times the breadth. And because the area of the rectangle at the bottom is equal to the area of the rectangle at the top, we multiply LB by 2, and that is why 2 has been factored out. So we have 2 into bracket LB. Now we will consider where LH and BH are all coming from, but for the meantime our concentration is on 2 times LB. It's on 2 times LB. That is, when we multiply area of the base by 2, we will get the area of the red shaded regions, the 2 red shaded regions, that is F, G, D, E and A, B, C, H. Now let's proceed. Now, considering the blue shaded region, we can also see that A, H, E, F and B, C, D, G are all the same. So we can calculate the area of one region and multiply the answer also by 2. Now, when we want to calculate the area of the rectangle BCDG, is the breadth times the height, that is D times H. And because the region GBCD is the same as the region FAHE, that is why we multiply BH also by 2, and that's why 2 has been factored out. Now we know where BH came from. Now let's look at where LH is also coming from. Now, considering the shaded region, that is A, B, G, F and E, H, C, D, we can see that the sides of the rectangles are all the same. So if you want to calculate the area of the rectangle A, B, G, F, is the length times the height. Is the length times the height. That is L times H. And because the area of the rectangle A, B, G, F is equal to the area of the rectangle E, H, C, D, there is no need calculating all the 2 areas. So we only calculate the area of the rectangle A, B, G, F and multiply our answer by 2. And area of the rectangle A, B, G, F is the length times the height. That is L times H. So we multiply L by H. Take note that we are multiplying it by 2. So because in all these 3 cases, all the faces occurs twice, that is why we factor 2 out. So the total surface area will be 2 times LH plus BH plus LB. Take note, that is how we find the total surface area of a cuboid. So the total surface area is now equal to 2 times LH plus BH plus LB. Now let's take a look at this example and see how best we can solve this question. Consider the rectangular box below. Find A, the total surface area, B, the volume. Now this is a cuboid. The length of the cuboid is 5. The breadth of the cuboid is 4. And the height of the cuboid is 3. Now how do we find the total surface area and the volume? Let's look at the solution. Solution. The total surface area is equal to 2 times LH plus BH plus LB, where L is the length of the cuboid, H is the height, B is the breadth. And so now by substitution, the total surface area is equal to 2 times the length from the cuboid is 5 and the height is 3. So LH will be 5 times 3 into bracket plus BH. B is the breadth and H is the height. From the cuboid, the breadth is 4 and the height is 3. So we have 4 times 3 into bracket plus LB. L is the length and B is the breadth. The length is 5 and the breadth is 4. So we have 5 times 4. Now 5 times 3 is equal to 15. 4 times 3 is equal to 12. And 5 times 4 is equal to 20. So in all we have 2 into bracket 15 plus 12 plus 20. And this is equal to 2 times 47. That is when you add 15 to 12. The answer is 27. And 27 plus 20 is equal to 47. Now 2 times 47 is equal to 94. So the total surface area is equal to 94 centimeters squared. The total surface area is equal to 94 centimeters squared. II, the volume. The volume of a cuboid from the formula is equal to the length times the breadth times the height. And from the cuboid, the length is 5 centimeters, the breadth is 4 centimeters, and the height is 3 centimeters. So 5 times 4 is equal to 20, and 20 times 3 is equal to 60. That means that the volume of the cuboid is equal to 60 centimeters cube. 60 centimeters cube. Because centimeters times centimeters times centimeters is equal to centimeters cube. And 5 times 4 times 3 is equal to 60. So the volume of the cuboid is equal to 60 centimeters cube. Now example. Find the volume of a cube whose length is 4 centimeters. Now, if you are talking about a cube, with a cube, all the sides are equal. That is, the length is equal to the breadth is equal to the height. So from the question, we are given the length of the cube to be 4 centimeters. Because a cube has all sides to be equal, it means that if the length is 4 centimeters, then the breadth is also 4 centimeters and the height is also 4 centimeters. Now we have to find the volume of the cube. Now let's look at the solution. This is a cube. With the cube, all the sides are equal. So the length is equal to the breadth is equal to the height. So the volume, which is equal to the length times the breadth times the height. Because L is equal to B is equal to H. It means that the volume of the cube will be equal to length times the length times the length. And from the question, the length is 4. So we have 4 times 4 times 4. And the volume is equal to 64 centimeters cube. The volume is equal to 64 centimeters cube. Now let's consider the cone. A circular cone is a solid which has a circular base and tapers to a point at the point. A circular cone is a solid which has a circular base and tapers to a point at the point. Now this is how the cone looks like. This is our cone. V is called the vertex of the cone. O is called the center of the circular base. The base is a circle as shown. The base of the cone is circular. The base of the cone is circular. So O is the center of the circular base. VB, which is equal to L, is the slant height of the cone. OB, which is equal to R, is the base radius of the cone. VO, that is the distance from the vertex to the center of the circular base, is the H, that is the height of the cone. So VO equals H equals the height of the cone. Now the curved surface area of a cone is given by pi RL. That is the blue shaded area. The blue shaded area of the cone is the curved surface. So the curved surface area of a cone is equal to pi RL. The total surface area of a solid cone. If you talk about a solid cone, that means that the circular end is closed. The circular base is closed. And because area of a circle is pi r square, the total surface area of a solid cone will be equal to the area of the circular base plus the curved surface. And because the circular base has area pi r square and the curved surface has area pi rl, it means that the total surface area of a solid cone will be equal to pi r square plus pi rl, where pi r square is the area of the circular base and pi rl is the curved surface area. The total surface area of a hollow cone is equal to pi rl. If you talk about a hollow cone, that is a cone without a base. That is the circular end is opened. If the circular end of the cone is opened, it means that the total surface area of that hollow cone will be equal to the curved surface area, and that is given by pi rl. The volume V of a cone is given by 1/3 times the base area times the height. The volume V of a cone is given by 1/3 times the base area times the height. Now, let's look at this example. Find the volume. Find the volume of a cone whose base radius is 3 centimeters. Find the volume of a cone whose base radius is 3 centimeters and height is 7 centimeters. Take pi, that is the constant, to be 22/7. Now from the question, we are given the base radius to be 3 centimeters and we are given the height to be 7 centimeters. Pi has been given to be 22/7. So how do we find the volume of such cone whose base radius is 3 centimeters and height is 7 centimeters? Now we know that the volume of a cone is given by 1/3 times the area of the base, and because the base is a circle, the area of a circle is pi r squared. So the volume of a cone is equal to 1/3 times pi r squared times the height, that is h. From the question, we are given the radius r to be 3 centimeters and we are given the height h to be 7 centimeters. So the volume V is equal to 1/3 times 22/7 times 3 square times 7. So the volume V is equal to 1/3 times 22/7 times 3 square times 7. And the answer is 66 centimeters cube. That's when we multiply 1/3 by 22/7 times 3 square times 7. The answer is 66 centimeters cube. That's the volume of the cone is equal to 66 centimeters cube. Now, take this exercise. The volume of a cone with base radius 6 centimeters is 132 centimeters cube. Calculate the height of the cone. Take pi equals 22/7. Now from this question, we are given the base radius to be 6 centimeters and we are told that the volume of the cone with the base radius of 6 centimeters is 132 centimeters cube. That means that the volume of the cone is 132 centimeters cube and the base radius is 6 centimeters. Now we have to calculate the height of the cone given the constant pi to be equal to 22/7. How do we solve this problem? Now let me give you a hint. What you are going to do is to make h the subject from the formula V equals 1/3 pi r square h. After making h the subject from V equals 1/3 pi r square h, we now substitute V equals 132 centimeters cube and r equals 6 centimeters and the height will give you 3.5 centimeters. This is your exercise. Please, from V equals 1/3 pi r square h, make h the subject from the principle of change of subject and substitute V equals 132 centimeters cube and r equals 6 centimeters and the height will give you 3.5 centimeters. Now we consider the pyramid. This is an example of a pyramid. We have the base, that is A, B, C, D. That is the part of the pyramid on the ground. A, B, C, D. V is called the vertex. So V is the vertex of the pyramid. VO, which is equal to H, is the height of the pyramid. VBC, that is VBC, is a slant face. It's called a slant face. Now VA, which is equal to VB, which is also equal to VC, and is equal to VD, is called the slant edges of the pyramid. Take note, VB is equal to VC, is equal to VD, and is equal to VA. We call them the slant edges of the pyramid. The total surface area of the pyramid is equal to area of the net. Is equal to area of the net. So the total surface area is equal to the area of the polygon base plus the area of the triangular faces. The total surface area is equal to the area of the polygon base plus area of the triangular faces. Now this is the net of the pyramid. That is when we dismantle the pyramid. This is the figure that we are going to form. This is what we are going to form after dismantling the pyramid. We have 4 triangular faces in this case. We have 1, 2, 3, 4. The base is A, B, C, D, and we can see that it's a square base. So it can either be a square base, a rectangular base, a pentagon base, or a hexagon base. It can also be a triangular base. Take note. So A, B, C, D is the polygon base, and we have 4 triangles. That is 1, 2, 3, 4. So if you want to find the total surface area, of this pyramid is equal to the area of the polygon base. That is area of the base A, B, C, D, plus the area of the triangular faces. That is 1, 2, 3, 4. So we calculate the area of the triangular faces and we add it to the area of the base. That is A, B, C, D, and that will give us the total surface area of the pyramid. Take note, this is called the net of the pyramid. This is called the net of the pyramid. Volume of the pyramid is equal to 1/3 times the base area times the height. Volume of the pyramid is equal to 1/3 times the base area times the height. Now, the base area depends on the type of base given. If the base is a rectangle, then the area will be length times breadth. So take note, it depends on the area that you are given, the base that you are given. So the volume of the cuboid is equal to 1/3 times the base area times the height. Now let's look at this example. The height of a pyramid on a square base is 15 centimeters. If the length of a side of the base is 5 centimeters, find the volume of the pyramid. Now before we solve this question, let's analyze the question. The height of a pyramid on a square base is 15 centimeters. Take note that we are told that the base is a square. We have a square base. That means that the base of the pyramid is a square. And with a square, all the sides are equal. So the height of a pyramid on a square base is 15 centimeters. That means that the height is 15 centimeters. If the length of a side of the base is 5 centimeters, find the volume of the pyramid. Now let's solve the problem. The volume is equal to 1/3 times area of the base times the height. Area of the square base, because the base is a square, the area of the square base is equal to 5 times 5. That's the length times the length, because all the sides are equal. So area of the square base will be 5 centimeters times 5 centimeters, and the answer is 25 centimeters square. Now the volume is equal to 1 over 3 times area of the base, and the area of the base has now given us 25 centimeters square. So the volume is equal to 1 over 3 times 25 times 15, where 15 is the height. Where 15 is the height of the pyramid. Where 15 is the height of the pyramid. Take note, volume is equal to 1 over 3 times area of the base times the height. Now area of the base, because it's area of a square, because the base is a square, we find the area of the square base, and that is 5 times 5 centimeters, and this is equal to 25 centimeters square. So the volume is equal to 1 over 3 times the area of the base, that is 25, times the height from the question is 15. So the volume is equal to 125 centimeters cube. The volume is equal to 125 centimeters cube. Now we consider the sphere. And this is an example of a sphere. R is our radius. Take note that half of the sphere is what we call the hemisphere. Half of the sphere is what we call the hemisphere, and the radius is R. The surface area of a sphere is equal to 4 pi r square. The surface area of a sphere is equal to 4 pi r square. And the volume of a sphere is given by 4 over 3 pi r cube. Now take note of the formulas, they are very important. The surface area of a sphere is equal to 4 pi r square, and the volume of a sphere is equal to 4 over 3 pi r cube. Now if you want to find the volume of a hemisphere, take note, I said that the hemisphere is half of the sphere. So if the volume of the sphere is 4 over 3 pi r cube, then it means that the volume of the hemisphere is half of 4 over 3 pi r cube. I repeat, volume of a sphere is equal to 4 over 3 pi r cube. So the volume of a hemisphere, because the hemisphere is half of a sphere, it means that the volume of a hemisphere will be half of the formula 4 over 3 pi r cube. So the volume of a hemisphere is equal to half times 4 over 3 pi r cube. Now 2 goes into 4 2 times, and so we are left with 2 over 3 pi r cube. So the volume of a hemisphere is equal to 2 over 3 pi r cube. Now let's take this exercise. A hollow sphere was completely filled with 1 liter of water. A hollow sphere was completely filled with 1 liter of water. Calculate the internal radius of the sphere in centimeters. A hollow sphere was completely filled. Take note, was completely filled. It means that it was filled to the brim. A hollow sphere was completely filled with 1 liter of water. Calculate the internal radius of the sphere in centimeters. Take pi equals 22 over 7. Now, I'll give you a hint. 1 liter is equal to 1000 centimeters cube. That means that the volume is equal to 1000 centimeters cube, because from the question it was filled with 1 liter. So if 1 liter is equal to 1000 centimeters cube, then it means that the volume is equal to 1000 centimeters cube. Now volume of a sphere is equal to V equals 4 over 3. That's the volume of a sphere is given by 4 over 3 pi r cube. The volume of a sphere is given by 4 over 3 pi r cube. Now we are given the volume to be 1000 centimeters cube. Pi is a constant, that is 22 over 7, also given in the question. What we are not given is the radius, that is r, and that's why what we are calculating for. So we are calculating for the radius r, so r is question mark. Now what we are going to do here is to make r the subject by the principle behind change of subject. I repeat, make r the subject from the formula V equals 4 over 3 pi r cube. After making r the subject, you now substitute the volume, that is 1000 centimeters cube, and the pi, that is 22/7, and the radius is supposed to give you 6.2 centimeters. The radius will give you 6.2 centimeters. This is the end of the presentation.